record here, right? Okay, I'm going to share the Eclipse code with you. All right, here we have the organization of the project over on the left pane. In the class project 3 version 1. This is the same thing that is on the D2L site. Let's ignore this application package, but there are 4 other packages here. You can see that one of them is named model, second one is view, third one is controller, and there is a fourth one called GUI. And if you expand this, actually it has it is a few packages. One of them is controller, the other one is view. So there are some names repeating. Why is that? What is this? What are these packages for? Okay, we are organizing this program into 3 subsystems. We are using what is called an architectural pattern, which is a way of designing a system as opposed to a small part of an application. And we are saying we will split this into 3 different modules with clear responsibilities. One is the model. It stores the data. So if you have an online store, for example, then the database, the products and member information, all that stuff would be stored in the model. It will contain the software for accessing the data, etc. It is not going to be a visual system. I mean, you don't have a graphical user interface built into the model. It is just the database, essentially, and the ways of satisfying your queries and so on. Then you need to see the data. So that is the view. And we need to also provide input that would be the controller. So if you have a online order processing system, online store, then your web browser is essentially your controller. That is where you actually type in your commands and so on. And the web browser is again your view. That is where you see your results. And the model is at the server where they are processing all your requests. So this enables us to produce systems that have loose coupling and a lot of cohesion. And once again, let me say, this is an architectural pattern. It is a way of dividing a system into subsystems, whereas a design pattern takes a small part of a problem and then says, okay, I need these such and such classes and such interfaces to do this part of the problem. Okay, so it is having a, rather the architectural pattern has a much larger scope. It is a way of designing a system. So when we look at the system, we are saying, this is the strategy that I'm going to employ. So in this program, we are storing all the shapes that we draw in the model. The controller will accept inputs, like if you wanted to draw a polygon, the controller will handle that request, and all the shapes will be displayed by the view. So that is the function of these respective 3 packages. But then what is this doing here, the GUI? The GUI is there because we want to separate out the Java FX code from the rest of the system, or any other visual technology. For example, if you wanted to take this to Android, hopefully all you need to do is replace this GUI with the Android's way of displaying graphics. That's all you really need to do. Okay, but of course, because of the way and cell phones work, you may have to employ some other techniques, like you might want to start threads and stuff like that. Otherwise the cell phone won't work all that well. So you probably want to do a little bit of tweaking in terms of invoking these three modules, but essentially the design wouldn't really change. Only the GUI would be replaced. Or if tomorrow Java comes up with a new way of drawing stuff, then you would replace just this package, nothing else. Everything else can remain the same. So that is the model view controller. Okay. And the purpose of the GUI, once again, is to isolate the technology dependent part. I mean, not that Java is not technology, but I'm trying to isolate the effects part of it from the rest of the system, so that we can replace it with Swing, we can replace it with Android, whatever. All right. And if you look at these different packages, you see a large number of classes. It is nothing to be scared about. All these classes are very small. And once you understand what they are for, it becomes a lot easier. So let me summarize what these classes are for, and then we will trace the flow of control when we draw a line. All right. When you invoke the drawing program, let's do that right now. You probably can't see this, so I'm going to change the sharing. Okay, so here is the drawing program. You can click a line, the line button, and then you click two endpoints and you get a line. Or you can draw a polygon by clicking all the vertices. And once you decide that you have the last vertex, you hit the enter key and it completes the polygon. You can save your drawing, open a drawing that you have saved. You can undo the operation. You can redo the operation. You can also draw labels. So you can type in something here. I can keep clicking and drawing labels, and then once I finish the last label, I hit the enter key, and that is confirmation that I am done with my labeling. So when I click the buttons or click the mouse or invoke the menu, okay, let me kill all these things. When you the button or the panel where the drawing appears, of course, it is going to be received by the graphical user interface. You know that there has to be listeners and so on and so forth, but there is no such thing in this controller package. In this MVC part of the system, there is no knowledge of buttons or other kinds of other very effects kind of events. But here, what we have is something like abandon event. That is, if you want to stop drawing a shape in the middle, you press the escape key. That really comes as an abandon event. Or delete character event. There is no such thing in JavaFX as delete character event. Or create line event, confirm event. So these are all more application oriented at the application level, at a higher level of abstraction, as opposed to clicking a button or clicking the mouse. Of course, I have things like mouse enter event and mouse exit event. I don't know. I didn't know what else to call them. That's why. Undo, redo, etc., etc. So whenever you have a new type of event, for example, if you're creating a new shape, for example, creating a circle, you need an event here. So as you add more and more shapes, you will have more and more events here. And as you handle more and more clicks and those kinds of things, you will add more and more things here. If you have more and more menu items, you will have more and more events here. So you need some basic set of things. After that, it is just one addition for one extra class for each event. That is that. Then what I have done is every shape is drawn in a separate class. So I have label drawing state where only label is drawn. Line drawing state, that handles drawing the line. Polygon drawing state, the polygon gets drawn in this state. Quiescent state, quiescent meaning nothing is happening. So when you start the drawing program, the system is in the quiescent state. And you can see that this package is called states. And you know that in the state pattern, we have a context. So drawing context is the one that stores the current state and any common data, which we will see in a minute. So if you look at the GUI, though, there is a controller package under GUI, and you can see a lot of JavaFX code here. For example, GUI button. You can see that there is a lot of JavaFX stuff, right? So this is very similar to the GUI button in microwave. The label button is a GUI button, etc. And then we have other things like what should you do when when a key is pressed. Okay, like if you hit the enter key, what should we do? So all that JavaFX code is over here. And before we, okay, let's look at a couple more classes. Key typed handler, that is, if you type in letters and digits, control comes here. Mouse clicks are handled over here. I handle two types of mouse clicks. One is normal clicks. The other one is with control pressed. I'm not sure what I'm going to use it for. Actually, I know, but I'm just putting it here for a later version of the drawing program. We will get to that at a later point. Maybe not this week, not even possibly next week. Then we have the drawing program here, which is also JavaFX code. And it consists of two panels, a drawing panel and a button panel. The code for which is here. The drawing panel is going to contain an FX, is basically an FX panel. The FX panel is going to contain a canvas. So this is where all the drawings occur, on a canvas. You have used a canvas in the third assignment, individual assignment. You remember drawing those triangles? So this is that. And the buttons are arranged in another JavaFX container, a vertical box, and you have all the buttons stored over there. Okay, let's not worry about the views at this point. So it is time to probably, oh, no, before we go there, one more thing. The model contains a package called shapes. So we have a superclass called shape. Okay. A shape can render itself. You can set the color of a shape, and that is essentially it. But it is subclassed by things like line. A line has more things, like it has 2 points, for example. A polygon has an array of points. You have kind of seen all these classes in some of these classes in, I think, the second assignment, probably. I think you did. And the model itself is a collection class, like your member list or product list in your first group project. So it contains a list of all the shapes that have been created. So you can do things like adding a shape, removing a shape, getting all the shapes, etc. I don't want to get into too many things at this point, because there is, how do you see the drawings? That is something that we haven't really covered at all. Let's first see how control flows when you click the button to draw a line. So any questions before we go there? Okay. When you click the line drawing button, you can see that the line button is here, and any click on that button is handled by the button itself. And what it does is the following. It knows that a button has been clicked, and the way that events are handled, except for a couple of events, is you simply deliver that event to the context, the drawing context. That is all the FX code knows, that there is a drawing context to which you have to ship that event. So what the line button does is it creates an event, but it is a singleton. So create line event dot instance, and that is over here. Create line event. It's a very simple class. There is nothing really except code to make it a singleton. So it calls that method in context with this as the parameter. Where were we? Line button. So it calls this method called handle event in drawing context with a line event as the parameter. So we get into drawing context. The drawing context maintains the current state, and it also keeps track of what is happening. So what command is the user doing at this point? We will get to that in the context of drawing the line. So just remember that there is a field called command, of type command, and this keeps track of the current command. And this keeps track of the current state. The methods of this context are extremely simple. When you create a line event, control comes here, and drawing context doesn't do anything with it except send it to the current state to handle. It is for the current state to decide what to do with this, to ignore it or do some processing, whatever it wants. That is going to be the case for most of these things. You can see, simply tells the current state. So the code is extremely simple. It is just a router that sends the event to the current state. Once again, like the microwave. So what we need to do now is go and see what the current state is. Okay, yeah, we didn't do that, right? So how do we know what the current state is? Well, if you look at the drawing context, the way it is initialized is it sets the current state to quiescent state. So the current state when the drawing program is started is quiescent. It is not doing anything. Okay, so it is in the quiescent state. So what if you click the line drawing button, then the quiescent state will get that event. So control will come to the quiescent state to handle the create line event. And what it does is, okay, right now I am doing nothing. Right now the drawing program is idle. I am getting this request to draw a line. So I'm going to change the drawing context to change its state to line drawing state. That's it. So you can see that there isn't much code here either. So things go to the line drawing state, which is here, which is slightly larger, but not very large at all. So what have we done? We have gone from quiescent state to line drawing state. And line drawing state is here. It is also a singleton. So it has just one instance method, and that is handle event to handle point inputs. When does point input event occur? So for that, let's go back to the interface. What has happened so far? You have clicked create line button, and inside the state has now become line drawing state. Now you will move the mouse to the drawing panel and click on the panel, on the canvas. So the mouse click handler will get that mouse click. So control will come here. When you click on the mouse, control will come here. And what does it do? Control comes to this particular line because the control button is not clicked. So we are assuming that only the mouse is clicked. So it goes to the drawing context's handle event method for a point input event. So I'm translating a mouse click to a more application oriented class object that is a point input event. I ask the mouse event, where were you clicked? What is the X coordinate and what is the Y coordinate of the place that you were clicked? So those two are put into the point input event, which is of course in the events package. Point input event has an X and a Y. When you create it, you pass the X and Y, and you can get the X and Y. So we again go to the drawing context, and we get the point input event. So and what it does is it tells the current state, handle this event. And what is the current state now? Line drawing state. So go to the line drawing state. You get an event. Okay. Now, when you get a mouse click, when you get a point and you are in the process of drawing a line, you get a point input. This could be the first point, or it could be the second point. If it is the first point, what we will do is this part. If it is the second point, then we do this part. How do you distinguish between these? We create, or we have in the drawing context, a field. You remember that? In the drawing context, we have this field called command. This command tells the system what is going on. So if you are drawing a line, this would be the line command. So if there is nothing in that command field, so there is a getter for that command. If it is null, it means there is no command going on. So now we say, okay, we create a line command. We need to explain this in detail. And we update the view. I'm glossing over the details of this. I will explain this in a few minutes. But I just want to give you the basics of the code. We have to explore this in detail. So we create a line command object, set the command in the drawing context to line command. You remember that a line is being drawn, and we prepare for undoing this command, and we update the view so that the starting point is visible. But the next time you get a click, you will come here again because the state hasn't changed. At this point, command will not be null. So you will come here and you will be setting the second point of the command. There is some unnecessary code here, but anyway, don't worry too much about it. And then we reset the command to null because we have finished line drawing, and we change the state to quiescent state, and we end the command. So I know there are a few questions that we haven't answered. What is this command doing? What is this business of beginning a command and ending a command? What is undo manager doing? How is the line actually shown? So that is what we will handle in the rest of the lecture. But before that, are there any questions? Okay, now I need to stop this share and explain what happens when you actually get a command going. So the model keeps track of shapes. So if you drew a line, there will be a line here, line 1, then maybe you drew a polygon, the polygon 1, then you drew a line, then line 2. So all the shapes that you draw are in this model. And we would like to provide the ability to undo and redo. And we also want to obviously see this on the screen. So you want to see the lines and the polygons on the screen, right? So this is the view. We would like to do undo and redo. So let's explore what needs or what is happening inside the system to handle all these requirements. Let's first talk about undo and redo. To handle undo, what we do is when we get a line, suppose there is a line that is from, that is like this, from this point to this point, from this XY to this XY. We wrap this, I mean, in the context of drawing a line, what did we do? We clicked the line button, then we clicked a point, then we clicked a second point. All these actions resulted in a line object with two endpoints. So all the actions can be captured. Having a problem with the pen. Okay, all the actions can be captured in a command object. All right. So this is an object that represents the entire command of creating a line, including the shape. So it has, the command object is going to contain the shape and ways of undoing and redoing. So it stores the shape, the command object stores the shape, which is the line in this case, and it also provides the basic ability to undo and redo that command. Okay. So there is going to be a command object for every command that you issue, or at least most of the commands that you want to be able to undo. There is no command object for saving a drawing. When you save a drawing, it is not undoable. So I'm not going to have that command object. So there is going to be a command class for line, a command class for polygon, a command class for circle, rectangle, anything that you can think of, all the shapes that you can think of. So that package commands will contain one class for every command that you want to undo. And among the major methods of this command class are undo and redo. What happened? So there are a number of command objects. So if you created a couple of lines and a polygon, there will be 3 command objects. And somebody has to keep track of all the command objects. So if you have 3 command objects, line command 1, line command 2, and line command 3. Okay, 3 lines, that's fine. Then somebody has to remember all the commands, because when you want to undo, you have to know what command to undo. So there is going to be a stack. Suppose this was the first line command. We will push this all the way to the bottom. Then suppose we create the second line, a line command exists for that. This will point here. And the third one will point here. So if you had 1,000 shapes, there will be 1,000 elements here. This is how undo is done in any system. Okay, you have a stack, and I call this, I think, the history stack. And when you want to undo something, you press the undo button. And what does the system do? What does the controller do? It looks at the top of the stack. The top of the stack says, this is the command to undo. So the system will say, okay, it will tell this command to undo itself. And then it will pop this. This is going to be gone, and it puts it into a redo stack. So this will be popped and pushed here. So you will have this will go, and instead we have the redo stack is here. Now, if you press redo, the system will check the redo stack and redo this command. So this will go from here back to here. This will go away, and then it will be pushed. If you undid three things, then it will undo this. This one, it will be pushed. It will undo this, it will be pushed. It will undo this, it will be pushed. This will be empty. You won't be able to do any more undos because there is nothing to undo. You can only do redos. You can redo the last, I mean, the top one, which means the first command, and so on. That is the plan. Questions? Okay. And we saw that every command is going to contain the shape. So line command contains this line command contains some other line, this line command contains some other line, etc. And they are all stored in the model. So what does a command object do to undo itself? What it does is it simply removes or removes things from the model. So if you ask this line command to undo itself, it will simply remove this line from the model. So it won't be seen anymore. If you ask it to redo, it will simply put this back into the model. Let's see that code. If you look at let's look at the controller commands package. There is a superclass called command, which is abstract. It has some few abstract methods and an end method, which I added. Typically, you would see, if you look at the literature, undo, redo, and execute. Okay, but you can modify things to your needs. So if you look at the line command, it extends command, it stores a line, and if you ask it to undo, what it does is it removes the line object from the model, model.instance.remove the shape which I have stored over here. And if you ask it to redo, it will call execute. Execute is here, which adds the shape back to the model. Very simple. And there is a class called undo manager, which stores the history and redo stacks. It is a singleton, as you can see here. And when you begin the command is pushed onto the history stack. And for convenience, I'm clearing the redo stack. So the moment you start a new command, the redo stack is gone. Otherwise, you can get into inconsistencies, which I don't want to handle. And when the command ends, you definitely want to be sure that everything is visible on the screen. So that is, we are calling update view. And undo is done here. If the history stack is not empty, get the top command and ask it to undo itself and push that command to the redo stack. Similarly, when you are asked to redo something, See if there is anything in the redo stack. If so, pop it and put it into the history stack. And you also want to redo that command. So actually, the undo manager is a fairly simple idea. You can determine the granularity of the operations. Do you want to, when you type in characters in a word processor, for example, what do you want to undo? Characters or words or lines or paragraphs? That's all up to you, the designer. Okay, you can see what Word does or Eclipse does. You can try undoing your typings and see at what level it is operating. Okay. Questions before we look at how things are actually made visible on the screen? All right. Things are, of course, drawn on the screen by a class, by view. So there are a couple of, actually three things under the view package. And these two are physical view and renderer are interfaces. View is a class. So the view is an observer of the model. So it tells, when it is started, it tells the model, please add me as your observer. And when the model changes, it calls the view to update itself. And what, so that needs to be explained. So let me go back to the whiteboard. So what we want to do is we want to handle things like FX, uh, swing, different types of technologies, maybe even the old abstract windowing toolkit from 1997 or whatever, the first version of Java, or maybe anything that comes in the future. Okay, so regardless of what we have, what kind of shapes we have, we would like to be able to draw them on all kinds of technologies. Suppose we want to do that. Then how do you handle this? There are a couple of options. If you look at a line, the line class knows where the two endpoints are. So there is a case to be made for saying the rendering of a line has to be in the line class. But then I would like to keep this away from the Java FX world. If that is the case, then we could say to draw a line, Java FX is the place to go. But then Java FX doesn't know where the line is. So we have a problem. The line class doesn't know the technology, and the technology doesn't know where the shapes are located, what the shapes are, what the coordinates are, none of that. So we need to find a suitable approach. One, we could create a line class to draw for JavaFX, for Swing, for every conceivable technology, but then we are creating so many line classes. Then we'll have to create that many polygon classes, that many circle classes, et cetera, et cetera. That is just plain class explosion. So instead of that, what we do is create two hierarchies. One is the shape hierarchy, which we have seen. So there is a line, there is a polygon, there is a circle. I mean, if you have implemented a circle, that is. So they are all subclasses of shape. And we can also think of a hierarchy of technologies, different ways of rendering. So I'm going to call this the renderer hierarchy. You could have an FX renderer. You could have a swing renderer and some other renderer, art renderer, and so on. So you can add more and more renderers, you can add more and more shapes, but how do you get a line to draw using swing, a line to draw using FX, polygon to draw using art, all kinds of combinations. For that, what we will do is we will have some fundamental, in here, some basic drawing operations. And those drawing operations will be used by these classes. We will see the code in a couple of minutes. So line needs to draw a line. Polygon can be drawn by drawing a bunch of lines. A circle can be drawn by drawing an arc that is going all the way around 360 degrees. Label can be drawn, if you had a label, by drawing a sequence of characters, etc. So what we want to provide in the renderer is the ability to provide basic drawing operations, which can be used in whatever way these shapes want. So time to look at the code. So here is the renderer interface. Interface renderer, it can draw a line. It can draw a piece of text at a certain point. It can draw an arc starting at this angle, ending at this angle with this much radius and this as the center. Then this will do nothing, if you wanted to call it. Then this renderer can change the color. You can give a color red, green, blue values between 0 and 255. And the last one would draw a single point at this location, X and Y. It can be implemented in JavaFX or Swing. Let's take maybe one or two of those. So there are a couple, I think I have 2 renderers implemented. So there is an FX renderer here. FX renderer implements renderer, and it uses JavaFX code to draw text, draw a line, draw a curve, etc. Similarly, Swing renderer does something similar. This is how it draws stuff. Okay, so the 2 hierarchies of shapes and renderers are organized such that the shapes know where the renderers are. And that is called the bridge. This is the bridge pattern. By the way, the command idea for undoing is called the command design pattern. Okay. Now, if you look at the shape, let's look at line. If you look at the line class, one of the things you see here is render. It gets a renderer. It doesn't really know what type of renderer it is, swing or something else. And all it does is it knows it is capable of drawing a line. So it calls the draw method of it. If it is a swing renderer, it will draw using the swing technology. If it is a FX renderer, it will draw using the FX technology. And you can create more and more renderers. Okay. Now, going back to the packages. So we saw the renderer interface. We had a look at the view class. So when the model changes, here, when the model changes, when you add a shape, where is it? Yeah, if you are or removing a shape, it calls the update view method, which fires a fires an event to all the observers, and the view gets notified. What the view does is, this is also, if you look at this, there is no Java FX code here. So it is incapable, this class by itself is incapable of drawing anything on the screen. So there are a number of actual physical views which implement this interface, physical view. Okay. And the physical view is implemented by, obviously, some classes here. So let's look at the classes here. There is an FX view. There is a swing view. Okay. And there is an FX panel and swing panel. So how are they organized? The FX panel or the swing panel actually carries out the task of drawing things or setting up the environment for drawing. So this is the swing panel. Then there is an FX panel here. So it has all these FX related code for drawing things. The the swing view includes that panel. So it uses a swing panel, and the FX view stores the FX panel. So this is simply providing a way to this is a way to support an actual window on the screen. Otherwise, it is simply an enclosure for the panel, which makes the environment for drawing. Going back to the view, when the view gets a request to update, what it does is it tells every physical view, these are the physical views, like the FX panel or the swing panel, they are the physical views. They are all told that it is time to draw. And let's look at what the FX panel does. The FX panel gets a command to draw, and what it does is it tells the view, okay, here is a renderer that I have. Using this renderer, draw your stuff. So you are calling so the view class is calling this FX panel to essentially set up the environment for drawing. And the FX panel is saying, here is my renderer using which you have to draw. And the view gets back. This is a callback. So the view gets to draw. What is it? View. The view draw method is here. There is some unnecessary code here. Ignore all that. You can ignore this loop. That's a mistake. It shouldn't have been there. And what it does is it goes through every item in the model and tells every item to, or every shape to draw itself using this renderer. So that renderer, it could be an FX renderer or a swing renderer in this particular implementation, and they're all getting drawn on the screen. So that is how anything gets drawn. So it's a carefully constructed mechanism to ensure that the Java FX code is completely separated from the logical code. So this is all very logical. There is not, it is not dependent on the technology. You can't see anything that is really dependent on Java FX or Java Swing or any such thing. It is all just logic. You can easily convert this to say C sharp, for example, whereas FX is not that easily. Of course, you can probably write the equivalent code, but this is much easier to convert to C++ or any other language. In fact, you can even take this to some other system which supports Java, like Android. Okay, so that is a overview of the design of the drawing program. Next week, we will look at the code in more detail. So, and then week after next, we will see a little bit of stuff related to this. And then we will look at more object-oriented design principles. And that will be the wrapping of the course. Any questions before we start the class exercise? Anybody? All right, then let me go ahead and stop recording.